Hello students, today we are going to discuss in Laplace transform, one of the most important chapter in network theory. So, in any type of engineering examinations like your GATE, IS or any civil service examinations, this topic is very helpful for the students. In Laplace transform, what generally in engineering we have different type of transforms, that is your Laplace transform, Fourier transform, Z transforms, etc. So particularly in Laplace transform, we will apply in most of the electrical circuits. In electrical circuits, we have to apply the Laplace transform. It is one of the transform, or we have to convert the transform which converts from one domain to another domain. Like if you will transform from time domain to frequency domain, we can go for a Laplace transform. Similar applications also, like your in case of Z transform. In Z transform, like signal processing or in communications, in Z, as far as the Z transform is concerned, similarly that is your n to what, the f of t n to f of z, that is your in a discrete signal x of n is given, how to calculate the Z transform of that signals. Similarly, Fourier transform, most of the in communications system, we have familiar with the Fourier transform. Similarly, time domain to frequency domain. There are so many transforms as far as engineering point of view, that is your Laplace transform, Fourier transform, Z transform, etc. So Laplace transform, it is one of the most important topic in network theory. So that means it will convert from a time domain to frequency domain. If f of t is given, we have to find out f of s, or x of t is given, we have to find out x of s. So Laplace transform, the basic definition of a Laplace transform is what? That is your definition of Laplace transform, that is what? So in a signal or in a function f of t, or the Laplace transform of function f of t, the Laplace transform of a function f of t can be defined as Laplace transform of a function f of t can be defined as what? That is your f of s, f of t can be defined as f of s, where t is varies from 0 to infinite. So f of s, the standard function of f of t, the Laplace transform of f of t is your f of s, which equal to 0 to infinite f of t into e to the power minus st dt. This is very important as far as Laplace transform is concerned. For any function f of t, we are going to calculate, or we are going to find out the Laplace transform f of t is nothing but f of s. A t domain is given, we have to convert it into s domain. What is s? S is a complex frequency. S is nothing but your complex frequency. S is nothing but a complex frequency, and S can be defined as S equal to sigma plus j omega, where sigma is the Nepher frequency. Here sigma is nothing but your Nepher frequency, and omega is your radian frequency. Omega is your radian frequency. So any time domain function can be converted into Laplace transform. So by means of f of t, we can convert it into f of s. So in symbolically, you can represent f of t, Laplace transform of f of t is nothing but your what? F of s. If t domain is given, we have to convert it into s domain, that is your Laplace transform of f of t is nothing but f of s. Similarly, if f of s is given, so that's why if f of s is given, we have to convert it into time domain by means of inverse Laplace transform. By means of inverse Laplace transform, so inverse Laplace transform of f of s is nothing but is your f of t. If s domain, we have a s domain, we can convert it into, by means of inverse Laplace transform, we get that is your f of t. If time domain given, we can convert it into Laplace transform, is nothing but is your f of s. what is the standard function to find out the Laplace transform of any function f of t can be defined as f of s equal to 0 to infinite f of t e to the minus st dt, and the t value varies from 0 to infinite. The function varies must be 0 to infinite, and the limit is your 0 to infinite f of t into e to the minus st dt is your basic standard function and the standard formula to find out any function in time domain to convert it into the frequency domain, where s is nothing but your s equal to your complex frequency. S is your sigma plus j omega, where sigma is your Nefer frequency and omega is nothing but your radian frequency. So what are the advantages of Laplace transform? So any time domain can be converted into by frequency domain by means of Laplace transform. We have different type of transforms as far as engineering point of view, like your Fourier transform and jet transform, etc. But in case of Laplace transform, we are familiar with the Laplace transform and frequently applied with your network theory in case of electrical circuits. So one of the easiest way to calculate or to find out the Laplace transform as far as and with the help of the Laplace transform, the solution will be very and it will take the less time, and also in case of as far as in particularly in a differential equations, the solution of the differential equation can be easily solved by with the help of the Laplace transform. But previously what happened in case of the solution of the differential equation by means of two functions, that is one is your complementary function, another one is your particular integral. We have to evaluate CF and PI, complementary function and particular integral separately, and then we'll add it and find out the total solution of the differential equation by means of complementary function and particular integral. But in case of Laplace transform, a single solution can be obtained with the help of the Laplace transform. So Laplace transform is a very easy method, or we can frequently apply it in case of electrical circuit, particularly in resonance. Suppose there is a time domain function is given, we can convert it into the frequency domain by help of the Laplace transform, where s is nothing but your sigma j omega, and sigma is nothing but Neper frequency, and omega is nothing but your radian frequency. The most fundamental formula to find out the time domain of any function is nothing but f of s equal to f of t into e to the minus st dt. F of t will be given, if f of t given, directly you can calculate f of s by means of Laplace transform using this formula. But if f of s is given, if f of s frequency domain is given, we can convert it into time domain by means of inverse Laplace transform. So let us now do some the basic formula using this formula f of s equal to f of t into e to the minus st dt. We have to find out the basic functions of Laplace transform. So particularly if some basic functions we are going to calculate the Laplace transform of some basic functions. Some basic functions. So particularly first number one, suppose now we are going to calculate the Laplace transform of a constant function. Like suppose in integration, we will from very beginning we will start what is the integration of a constant function, but it will be 0. What will be the integration of a simple function x? What is the integration of by means of by parts, by means of product rule, different like that. But in case of Laplace transform, we will start Laplace transform some basic functions like a constant function. Suppose f of t equal to a constant function. F of t, suppose a constant function. F of t equal to k. K is a constant. K is a constant. K is a constant. K may be any value, maybe 1, 2, 5, 10, any number may be. F of t is a constant. How to find out the Laplace transform of that functions? Now we know that Laplace transform of f of t, Laplace transform of f of t equal to your f of s, and the formula is what? That is your the t value varies from 0 to infinite, and f of t into e to the power minus st dt. This is your general formula of find out the Laplace transform of any function f of t into e to the minus st dt. We have the f of t, we are going to convert f of s by means of Laplace transform. and here f of t equal to k. So that's why in place of f of t we can put that is your k, and limit is your 0 to infinite e to the power minus st dt. And simply as usual, to find out the basic principle of to find out the integrations. So this is a constant k taking the left side of the integration, that is your 0 to infinite e to the power minus st dt, which equal to k e to the power minus st dt. Integration is how much? That is your e to the power minus st with respect to t is nothing but what? Minus s, and the limit is your 0 to infinite, and the value is nothing but k by that is your minus s, and here put in place of t, here t is your variable, in place of t that is infinite, e to the power minus infinite, e to the power minus infinite is nothing but what? That is your 1 by e to the power infinite, and e to the power infinite equal to your infinite, and the value is your what? 1 by e to the power infinite, 1 by infinite is nothing but 0. So e to the power minus infinite is your 0. If you put the upper limit at t equal to infinite, e to the power minus infinite, that is your 0, minus put the lower limit 0, e to the power minus 0, e to the power minus 0 is nothing but e to the power 0, e to the power 0 that is 1, and here minus that first on 0 minus 1, this is 0 minus minus plus, it is nothing but k by s. One of the very important conclusion to find the time domain into frequency domain, if there is a constant function and the Laplace transform of that constant function is constant by s, here therefore the Laplace transform of k equal to that is your k by s. Laplace transform of a constant function is nothing but what? K by s. So Laplace transform of a is nothing but a by s. Laplace transform of 10 equal 10 by s. So any constant function Laplace transform that by s. Here the time domain, that is a constant function k, the Laplace transform of constant function k is equal to k by s. If you will reversely, if you will ask what is the inverse Laplace transform of k by s, if you will say it is nothing but your k. And so the Laplace transform of f of t, if Laplace transform of f of t is f of s, the inverse Laplace transform of f of s is nothing but f of t. Laplace transform of k equal to k by s, inverse Laplace transform of k by s is nothing but k. So this is one of the standard formula to find out the Laplace transform of a constant function. The Laplace transform of a constant function k is nothing but k by s, and inverse Laplace transform of k by s is nothing but k. And next we go to the next what? The second basic functions, that is your number 2, the Laplace transform of f of t, let f of t equal to t, f of t equal to t. Okay, f of t equal to t. So now we are going to convert or transform into the Laplace transform. So t domain f of t equal to t, we are going to calculate f of s. As we know that f of t and f of s are Laplace transform pair, that means what? We can say Laplace transform of f of t is f of s, and inverse Laplace transform of f of s is nothing but f of t. Then we know that Laplace transform of f of t equal to your f of s, and the formula is nothing but your 0 to infinite f of t into e to the power minus st dt. Okay, and here f of t value is how much? F of t equal to t. In place of f of t, you have to put t. Whatever the function is given, now we are going to calculate the transform, Laplace transform of f of t, that is t. So that's why whatever the value of f of t is given, put that value in place of f of t. So f of t is your t into e to the power minus st dt, and the integration limit is your 0 to infinite. And what we will do? One function, first function and second function, by you can apply the integration by parts. The first function u, second function e to the power minus st dt. First function, what is the formula to find out the integration of the with the help of the integration by parts? First function into integration of second minus integration of second into differentiation of first. So we can say that if u dv, the integration by parts, it is nothing but u into v. Integration of dv is your nothing but v, that is your second function. This is your second function, This is your second function and this is your first function, u into v. First function integration of second v minus integration of second function. Integration of second function is that your v into differentiation of first, that is your du. This is the formula of integration by parts. First function into integration of second minus integration of second into differentiation of first. U into v, we can say normally we can say ub minus v into du. If u is the first function, dv is the second function, integration of dv, that is your v. That's why u into v minus integration of v into du. Similarly here, what happened here? This your u is your t. U is your t, that is your t. Then dv. Where is your dv? dv here, dv is nothing but is your what? E to the power minus st dt. So integration of e to the power minus st dt. Integration, the integration of this is nothing but what? E to the power any function, integration of e to the power that function with respect to t is nothing but minus s. That is your this. So integration of dv, that is nothing but what? Second function is nothing but e to the power minus st dt. E to the power minus st dt is nothing but e to the power minus st by minus s. So that is your u, t, u into v. V is nothing but what? E to the power minus st divided by minus s. U into v. Then minus v into du. Whatever this, that is your e to the power minus st by minus s into u into v, v into du, t. T the differential is nothing but what? dt. This is your dt. The value is how much here? And you will put the upper limit, that is your lower limit 0, upper limit infinite. This is your 0, this is your infinite. Clearly, if you put infinite t value is your what? Infinite means e to the power minus infinite 0, 0 into anything 0. If you then lower limit, that is your 0 into anything 0. That means this it will be 0. So that is your here, and minus here minus becomes plus. That value is how much? That is your what? That is your 1 by s integration of 0 to infinite e to the power minus st dt. As you know that e to the power minus st dt, the integration of 0 to infinite e to the power minus t dt is nothing but 1 by s. In previous calculation, that is your what? Here, that is your e to the power minus st dt integration is nothing but what? That is your 1 by s. That is your k into 1 by s. Similarly, here also e to the minus st dt integration is nothing but 1 by s. Or you may find out that is your what? That is your 1 by s into e to the power minus st dt e to the power minus st, and this is nothing but minus s, and the value is your 0 to infinite, and it's equal to 1 by s into e to the power minus infinite 0 and e to the power 0, that is 1. And first limit is your 0, and this will be minus e to the power, that is your what? Plus 1 by s, and it is nothing but 1 by s square. Upper limit e to the power infinite minus infinite 0 minus plus, that will be plus e to the power 0 1, that is your 1 by s, and 1 by s, that is your 1 by s square. So therefore, what we conclude? Laplace transform of t equal to 1 by s square. It is very, very important. If a time domain only t is given, so Laplace transform of t is your 1 by s square. Or we may say inverse Laplace transform. Inverse Laplace transform of 1 by s square is nothing but your t. It is very, very important as far as most of the problems. If a time domain is given, we are going to calculate the frequency domain. If t is given, directly you can find out the Laplace transform. Laplace transform of t is your 1 by s square, or inverse Laplace transform of 1 by s square. 1 by s square is nothing but your t. This is one of the basic functions to find out the Laplace transform of a t. Suppose if I will say that is your t square, the value of the power of t is here, that is your 1. If I will say t square, Laplace transform of t square. Suppose if I will say Laplace transform of t square, what will do? So Laplace transform of t square is nothing but, already I told you, if f of t and f of s are Laplace transform pair, so Laplace transform any function, that is your what? The formula is your 0 to infinite, that is your t square into e to the power minus st dt, e to the power minus st dt. Here function f of t, here function f of t is your t square. So f of s is nothing but what? F of s is nothing but Laplace transform of f of t, and Laplace transform of t square equal to that function into e to the power minus st dt, and the value is how much here? If we will proceed with the help of the rule of the integration, that is your 0 to infinite t square e to the power minus st dt. Here the first function is t square and second function is your e to the power minus st dt. Here u, the first function u equal to t square, and du is nothing but that is your 2t dt. Similarly, dv is nothing but your e to the power minus st dt, and v is nothing but integration of dv is nothing but v, which equal to e to the power minus st divided by minus s. So that is your u into v. We have u into dv by means of by parts rule of integrations. U into dv equal to u into v minus integration of v into du. So that's why the first function u is your t square. So that's why u equal to t square, first function t square, that is your t square. So t square u into v e to the power minus st by minus s, u into v, limit is your 0 to infinite, minus v into du, integration v into du is not, v is your what? E to the power minus st by minus s into du. Du is nothing but 2t dt into 2t dt. This is the rule of the integration by means of by parts, first function into integration of second minus integration of second into differentiation of first. So u is your t square, v is your e to the power minus st by minus s, put the limit 0 into the 0 to infinite minus whatever this v, that is your e to the power minus st by minus s, v into du, t square differentiation, that is your 2t dt. And here if we put this value will be 0 because e to the power minus infinite 0, and here 0 t value 0 means t value 0. If you put value of t equal to 0 to anything 0, the whole value, if you put the limit lower and upper limit, the value will be 0. And here minus plus, that is your, which equal to, that is something by s, 1 by s, I can write 1 by s, that is into, that is your 2 is a constant taking to the left side of the integration, that is your what? Value of the limit of the integration, that is your lower limit is your 0 and upper limit is your infinite, and the value is nothing but is your what? T into e to the power minus st dt, t into e to the power minus st into dt. In the previous calculation, when f of t equal to t, then we have to find out f of t dt. T into f of t is your e to the power minus st dt. So this value is nothing but what? This value is nothing but t into e to the power minus st dt is nothing but what? 1 by a square. If you go from the previous slide, here t into e to the power minus st dt is nothing but what? 1 by a square. Here integration of t into e to the power minus st dt, or the Laplace transform of t is nothing but 1 by a square. So t into e to the power minus st dt is your 1 by a square. So t into e to the power minus st dt, the value is nothing but 1 by a square. So that is your 2 by s into 1 by a square, and the value is nothing but 2 by s cube. What we obtain? Laplace transform of, therefore Laplace transform of t square equal to, that is your 2 by s cube. So Laplace transform of t square equal to 2 by s cube. So inverse Laplace transform of 2 by s cube is nothing but what? That is your t square. So where already you know the Laplace transform of time domain is your frequency domain, and inverse Laplace transform of frequency domain is nothing but time domain. If the Laplace transform of t square equal to 2 by s square, so inverse Laplace transform of 2 by s cube is nothing but what? T square. So what we have obtained, if we observe the previous slide, Laplace transform of t is your what? That is your 1 by s square, and Laplace transform of t square is nothing but what? 2 by s cube. So if we observe, there is a rule So Laplace transform, what we got? T equal to 1 by a square. Laplace transform of t square, we have already obtained 2 by s cube. Similarly, if you will calculate Laplace transform of t to the power n, that is your factorial n by s to the power n plus 1. It is very, very important as far as to find out the Laplace transform of any power of t, that is your factorial n by s to the power n plus 1. We can check it also. Here, value of t, the value of n equal to what? N equal to 1. So n equal to 1 means what? If n equal to 1, then that is your what? Laplace transform of t. Here n equal to 1. T to the power 1 equal to 1. Factorial n. N is 1 means 1 factorial. 1 factorial divided by s to the power n plus 1. 1 plus 1. And 1 factorial is 1 by s square. So 1 Laplace transform of t equal to 1 by s square. Already we have derived. Similarly, if you say Laplace transform of t square, here n equal to what? N equal to 2. So Laplace transform of t square is nothing but what? We rule is what? Factorial n. N factorial. N factorial means n equal to 2. Factorial 2 divided by s by n plus 1. N equal to 2. 2 plus 1. And factorial 2 is nothing but 2 into 1 by s to the power 3. 2 into 1, that is 2 by s cube. So therefore, Laplace transform of t square equal to 2 by s cube. The rule is satisfied. If we will say Laplace transform of t to the power 3, if you will say Laplace transform of t to the power 3, you can easily calculate, that is your factorial n. N is your 3. So factorial 3 divided by s to the power 3 plus 1. So factorial 3 is nothing but 3 into 2 into 1 and s to the power 3 plus 1, that is 4. And this will value is nothing but 3 into 2 6. 6 by s to the power 4. So likewise, you may calculate Laplace transform of any power of t. T to the power 3, t to the power 4, t to the power 5, whatever value of power of t, you can use this rule, factorial n by s to the power n plus 1. So what we have concluded from the beginning of the class today, that is we have what do you mean by the Laplace transform. The Laplace transform of any time domain, we may convert it into frequency domain. The time domain can be converted into frequency domain. A very standard formula, f of s equal to 0 to infinite e to the power minus st dt, where the value t varies from 0 to infinite. So Laplace transform, it is a very easily a method which can obtain a very less, it will take very less time, and it can be applicable in most of the electrical circuits, particularly in transients. Transient means suppose inductor, capacitors, and some DC voltage is given when the switch is open, which switch is closed. So what happened? The position of the inductor and capacitors. So that's why in a Laplace transform, we conclude that from basic function of Laplace transform, a constant function, Laplace transform a constant function is a constant by s. We have derived Laplace transform of k is nothing but k by s. We have derived also Laplace transform of t is nothing but 1 by s square. Laplace transform of t square also we have derived 2 by s cube. Then only we have concluded Laplace transform. So t of any power equal to that power factorial of that power by s to the power n plus 1. So Laplace transform of t to the power n is nothing but factorial n by s to the power n plus 1. So okay, we will do more and more number of problems in the coming classes. So how to find out the Laplace transform in exponential function, hyperbolic functions, and also Laplace, some initial value theorem and final value theorems. There are so many how to calculate the Laplace transform from differential equations. So thank you students, we will meet again.